Welcome to Smart Sessions by Smart Interviews. In this video, we are going to solve this linked list problem called reversing a linked list. I recommend you pause the video here, go through the problem, and come up with an approach. You can find the problem link in the description. Okay, now let's see how we solve this problem. The problem statement goes something like this. You have a linked list and you have to reverse the linked list. So when you reverse this linked list, you get something like this. You get your head will be having -7, and then you'll have 9, 3, -6, 2, and 4. When you reverse this linked list, you get something like this. You have to reverse the given linked list. So how do we do it? So first of all, the basic idea behind this is we have to just reverse every link. That is the basic idea. Now, how do we reverse every link? So first thing that we have to do is, as you can see, the current head is pointing to node 2. But if you look in the output, the head node, the previous head, should be pointing to null. So let's first do that. I'll do head dot next is equals to null. So what will happen when I do that? My head dot next will be pointing to null. But if I do this, my link to this pointer or the link to the next node is lost, and I don't have any way of going to the next node. So to fix this issue, what I'm going to do is I'm going to take a pointer, let's say t. Okay, let's take a pointer t, and I'm going to initialize, or I'm going to give it a value of head dot next, or I'm going to point the t to head dot next. Okay, so now my t is over here. Okay, now I have a pointer to keep track of the next node. So what I can do head is equals to t. I can do head equals to t. Now when I do head is equals to t, my head is going to come here, but now I should link this 2 to the previous node 1. But now I don't have any way to do that. I don't have any way to link my head to the previous node. So to fix this, I'll simply take another pointer, let's call previous. So it'll be something like node previous. It'll be initially equals to null. Now what I'm going to do is I'm going to, instead of giving the head dot next as null, I'm going to point it to previous. And once I'm done with that, I'm going to move previous forward, and I'll do previous is equals to head. Now if you look at this, let's trace this code for the first step and see what will happen when I do this. So initially my head is pointing to the head node, and previous is pointing to null, and temporary is not initialized yet. So when I execute this line, temporary will be pointing to 2. Now if I do head dot next is equals to previous, since previous is already pointing to null, head will also point to null. Once that is done, previous will move to head, so previous will come to head, and then head will move to t. This is one step. Again, let's continue. Let's go to the next step. When I go to the next step, t will go to head dot next again. So t will go to head dot next. Then head dot next will become previous. So head dot next will be pointing to previous. And then previous will come forward to head, and head will come forward to t. Right? Let's continue this again. So again t will move forward. Now if you look at here, at any point we are having 3 pointers. One is going to point to the node which is after head. One is going to point to the node which is before head, so that we don't lose track of the next and previous nodes, and we can move freely and easily. At every step we simply link the head node to the previous node. So first step is done. Now let's go to second step. So I'm going to link head dot next to previous. Then I will move previous to head and head to T. Again the same thing, head will move, T will move forward, and then what will happen, heads next will be pointing to P, and then P will move forward, and then head will move forward. Same thing again, T will move forward, then head will be pointing its next to P, then P will move forward, and then head will move forward. At the end, finally, again T is going to move forward. It will move to null because currently head dot next is null. So T will be moving to null. Then heads next will be pointing to previous, and then head will be moving. Previous will move to head, and head will move to null. Done. As you can see, now every link is reversed. So this is how we reverse a linked list. As you can see, we stopped doing this when head reached null. So as long as my head is not equals to null, I'll keep doing this. So this is the basic idea behind how we reverse a linked list. Now let's code it up and see if it is going to work. So first, what should we do? We should first initialize our P and T. So list node P or previous is going to be equals to null initially, and I'm also going to declare T. We don't have to initialize T. T will be initialized. It will be given a value in the while loop, so you don't really have to initialize T. Now while head is not equals to null, what should we do? We should first do T is equals to head dot next, then head dot next equals to previous, and then previous is equals to head, and head is equals to T. This is the basic idea. And finally, what should we return? So if we go back to our screen over here, so as you can see, we have to return head, which is -7. The new head of the reverse linked list will be -7. Now, and as you can see, P is pointing to -7 over here. So we will simply return P. And let's do that now. I'll simply return previous. Let's run this code. It got accepted for the sample test cases. If we submit, it got submitted. That's it. See you in the next video. Thank you for watching. Please like, share, and subscribe for more such content.